This is a question involving refraction. So we have been given there is a beam of light which is passing from medium X into medium Y. As we can see that the light ray is actually bending away from the normal. So how do we approach these questions? In all questions of refraction, always start with the Snell's law. Now Snell's law states that the product of the refractive index n with the sine of the angle of incidence is always a constant. N sine theta is a constant. So let's apply that logic here. In the medium x, let's say the refractive index is nx. So nx stands for the refractive index for the medium x multiplied by sine of the angle in that medium. So if you observe this diagram, theta I is the angle of the beam with respect to the normal in the medium x. So we will write sine of theta I will be equal to the n sine theta for the medium y, which will be written as ny multiplied by sine of the angle in medium y is theta r. So we write theta r. Now in the question, it's given if the angle of incidence of light increases, which means theta I is increasing. Which of the following changes can be implemented to keep the angle of refraction the same? Angle of refraction is theta r. So first of all, let us make sine theta r as the subject to figure out on what parameters theta r depends. So if you make sine theta r as the subject, we will write nx sine theta I divided by ny. It's given the angle of incidence of the light increases, which implies theta I is increasing. Now we want the theta r to be the same. Now if theta I is increasing, for theta r to be constant, the nx value should decrease. So let's write down nx value should decrease. Let's repeat. Since theta r is a constant, which means this entire right-hand side needs to be constant, but theta I was increasing, that is only possible if nx is decreasing, which means if we look at the statement 1, medium x can be replaced with another medium with a lower refractive index. This, in fact, is correct, which makes the statement 2 incorrect. Likewise, if we look at ny, again theta r is supposed to be constant, and if your theta I is increasing, so ny also has to increase. So we can say that theta r, the sine theta r is directly proportional to sine theta I divided by ny. Now in the question, theta I is increasing. So ny also needs to increase. Only then the sine theta r will be a constant. So that's why medium y can be replaced with another medium with a higher refractive index. So ny needs to increase, which means statement 3 is correct, which means our final answer is option B, 1 and 3 only. In this question, two charges of Q and 2Q are fixed in the given positions, and both of these charges are positive. The question is at which position out of A, B, C, and D is the electric field equal to 0? So we need to find out the electric field, the net electric field due to Q and 2Q combined. So how do we approach this question? So remember, whenever we have a positive charge, electric fields always originate outwards away from the charge. So if I focus on Q, let's try to figure out the electric field at A due to positive Q. So this, since the Q is positive, electric field will go away from it in this given direction, which means at point A, the electric field is towards the left-hand side. Now, similarly, if I consider 2Q, the electric field will again be outward. So we draw this arrow while intersecting A. So now observe, because of Q, electric field is leftwards, and because of 2Q, electric field at A is also upwards, which means if, let's say, we have to find out the net electric field at point A, all we need to do is we just add the two electric fields. Since the two arrows are in the same direction, we will write EQ plus E2Q. That will be the net electric field at point A. Now, in the question, we are supposed to find, is it possible that at point A, the net electric field becomes 0? So we can see here we have sum of two numbers, sum of two positive numbers. Now, sum of two positive numbers can never be equal to 0, which means option A is not the answer. Moving ahead, let's analyze D. So we apply the same logic for D. If I consider Q, so Q is positive, so the electric field line will go away from it, and at point D, we'll check the arrow is going rightwards. Now 2q is again positive, so the electric field line will go towards the right. Even in this case, the net electric field is additive because the two arrows are in the same direction. So using the same logic as A, even at D, the net electric field can never be equal to 0 because it's the sum of two positive numbers. So hence, D is also not the answer. Now let us check point C. So let us draw the electric field lines. Due to Q, it will be towards the right, and due to 2Q, it will be towards the left hand side. So in this case, you can see that the two arrows are in the opposite direction. So we will write that the net electric field at point C will be the subtraction of 2. So electric field E2Q minus electric field due to Q. Now we need to check, is it possible that this expression becomes 0? For that, we look at the expression of electric field, we know that is kq by r square. So if you observe point C and let us analyze the electric field due to 2q, observe that 2q is at a less distance from C as compared to q. Let me repeat, the point C is closer to 2q than q. And since electric field is directly proportional to charge and inversely proportional to distance, we can say that electric field due to 2q at the point C is actually greater than electric field due to q at the point C, which means the net electric field at point C still will not be equal to 0. Hence, even C is not the answer, which leaves us with option B. That is the answer, but let's quickly analyze why is that. At point B, again, we draw the electric field lines due to the two charges Q and 2Q. And even in this case, you can see at point B, the electric fields are in the opposite direction. So we will subtract the two. So E2Q minus EQ. For the point C, which we discussed earlier, we saw electric field due to 2Q was greater because the point C was closer to C. But if you observe B, B is closer to Q than 2Q. And let's write down the basic formula again, kq by r square. Electric field is directly proportional to the magnitude of the charge and inversely proportional to the distance. So in this case, it is possible that the value of E2Q should be equal to electric field due to Q. And why is that? Because the point B is closer to point Q. Q is the smaller charge and 2Q is the bigger charge. So B is at a far off distance. So it is possible that these two electric fields could be equal to each other. And just to cross check, where is that point? So let's say if we assume the distance between Q and 2Q, let's say that is A. And let's say that the point B is at a distance of X away from Q. So let's draw that arrow. Point B will be at a distance of X. So although we have gotten the answer as option B, but just for the sake of understanding, we are trying to find what will that value of X be. So where will B be located? So electric field due to 2Q, we write down the expression K into 2Q divided by distance squared. So what is the distance of 2Q from the point B? So we can see that will be A minus X. So A minus X whole squared. That will be equal to EQ. Electric field due to Q will be KQ divided by, and we can see distance is X. Distance of point B from charge Q is X. So we will write in the denominator X squared. And let's simplify this. So we can see the K will get cancelled out, the Q will get cancelled out, and let's cross multiply. On cross multiplication, we'll get 2x square is equal to A minus X whole square. To simplify this, we take square root on both sides of the expression. So if you do square root, let's write down the expression. So we'll have root on both the sides. So the expression becomes root 2x equals to A minus X. Let us make X as the subject from this expression. So we'll get root 2x plus X equals to A. We'll make X as common. In the bracket, we'll get root 2 plus 1. And if we make X as the subject, we will get A upon root 2 plus 1 as our answer. Now, although we were not supposed to find X, that was just for your concept level understanding. For this question, all we needed to do was B was the point since it is closer to Q, which is the smaller charge, and it is further away from the bigger charge. So it is possible that the two electric fields can cancel each other out. And that's why option B is the answer for this question.